Good morning, everyone. Can you hear me? Yeah, good morning. Good morning, all. Very good morning to everyone. Thank you. Are you able to see my screen? Yes, your mic is disabled. Right. Yes. Thank you. Thank you. Thank you. Shall we start? It's almost 10:30, 31. Uh, Already we have 119. Yeah. Thank you. Yes. So, very good morning to everyone. Myself, Indumathi. I have been associated with BITS WLP division since 2021 as a guest faculty. So my research area and my other specialization would be like machine learning, medical image processing, deep learning, and deep neural networks. So, sorry. So before going to start with the actual agenda, I just wanted to introduce the course and the outline and all, right? So with respect to course administration, and have you all enrolled or in the e-learn portal? Have you all received it? Okay, you all received it, right? Okay, fine. Yeah, in the e-learn access. So are you able to get the course handout? It's in the first page. It's a taxilla. Yes, yes. E-learn means taxilla. Yes. So in the taxilla, course handout is available. Please download it. And in the taxilla only, we will upload the common, even though we have multiple or parallel sections, right? I hope you all aware you can have access to all other recordings, right? All other faculty recordings, right? So my teaching style would vary from compared to other professors, right? So you just check whichever is comfortable for you. You can proceed with that. It's your wish, okay? But you have that flexibility here. Yes, we have parallelly we have 5 sections, and all 5 sections recordings will be available to you, right? In the Teams, you can check it, and the course handouts will be, and the common PPT or the session PPT will be uploaded in the Taxilla portal. But the thing is, during the live session, if I have solved any numerical problem, that is, if I have explained anything in my slide, right? So with annotation, that PPT will be uploaded in your Teams. Is this okay? Okay. So far we have almost um, like participant 141, right? If I have enabled the mic, it will be like we cannot proceed further, right? So after 15 minutes or each and every after completion of 1 or 2 topics, I'll ask, right? So I'll ask I'll ask you to the about your query or about your understanding. If you have any queries, you can raise your hand. I'll unmute you. Yes, because it's not like only if there are 50 or 60, then we can unmute everyone. Otherwise, it will be like it's not in a proper way, right? Yeah. After completion of each and every topic, I'll ask you if you have any queries. Meanwhile, you can also post your queries in the chat, right? So I'll check. I mean, Parallelly, I'll check your queries in the chat as well, and then and there I'll try to answer. If not, still, if you want to enable your mic, please raise your hand. I'll enable your mic. Okay? Yes. Yes. Yeah. No, no, no. The slides without the live session slides will be available in the Teams, and the common slides will be available in the Taxilla. Yes, Gautam, math will also be covered here. Yes. So I'll share the entire screen first so that it will be, you people are first semester, right? So, right. Yeah. So just go to your eLearn access, eLearn portal, right? You'll be having the machine learning course here, this page. Yes. The course handout can be downloaded from here. Just click the course handout. The course handout will be downloaded. Yes. And general announcement will be available in this announcement portal and this platform, right? And what suppose if you have academic related query or class related query, assignment related query, you can post your queries or you can raise your query in the general discussion forum. Okay. Is this okay? Yes, you just click add discussion topic, give that a subject, and then what is your concern? You just write it here. Our TAs and the faculty can check within 48 hours. You will get the response. Don't worry. Yes, right. And okay, see here the previous year question papers, sample question papers also available in EC2 as well as EC2 means like mid semester and the comprehensive examination. All the previous semester sample question paper also uploaded in the Taxilla. Yes, even the lecture one, the current lecture, ML context session 1 and context session 2 have been uploaded already, right? The rest of the PPTs will be available in the lecture folder, lecture slides. This here, this in this desk, you can in this deck you can get all 16 context session. Okay, so try to explore this, and the annotated PPT will be available here. It will be available here. Yes. General. So in the Teams, you can go and check the in the like in my name under my name. You just click my name, and then you'll be getting some. Unable to stop sharing. There it is. Machine learning is given to me. Yes. I hope my screen is visible now. Yes. Yeah. So just go to the Teams. You can check all professors' names here, right? If you want to check my recording, click my name, Indumathi Prabhakaran. You'll be getting this kind of page. It's a general page. Just click shared folder, right? So as of now, and I mean, we have not yet completed even one session, right? So automatically one recording folder will be created after completion of first context session. The first recording will be available. I mean, hereafter the recordings will be, live recordings will be available here. And I'll create one more folder here for class material. Yes. Yes. So I have created the class material folder here. The annotated PPTs will be uploaded. And if I have implemented any real-time examples or the data sets associated with the data set as well as the IPython notebook, all implementation, if I have done anything in the live session, everything will be uploaded here with context session wise. I will create separate folder for context session and everything will be the live session materials and the annotated PPT, IPython notebook and data set associated with that data set, with that IPython notebook, everything will be available here, right? So session wise, I'll upload here. So this is about the course administration. Do you have any queries? If no, I can proceed with today's agenda. And one more important point, since it is your very first class, I have allowed or I approved for you are supposed to join through your BITS mail ID. Please remember, right? Hereafter, I will not approve if you are in the waiting in the lobby, right? So hereafter, please try to join through your BITS mail ID. Then you can directly join without getting my approval. Okay? Yes. Okay. Just yeah. Yes. Yes, Sarthik. Yes, please. Yes, please. What's your query, Sarthik? I hope you're all comfortable in this, right? So you don't have any queries regarding the post page access and the material access and all, right? Yes. Thanks. Thank you. I'll proceed. Do we have separate materials for live class and general material? Yeah. No. See, both are same. Whatever is uploaded in the Taxila, that is what I'm going to use it, reuse it here. But the thing is, what suppose if I have solved any numerical, I'll write here, right? No. So I'll annotate the content in the PPT. So the annotated PPT will be available in your Teams. That's it. That is the difference. Both are same. Both PPTs are same. That is without annotation will be available in Taxila. With annotation will be available in your Teams portal. Yes? Yeah. Yeah. Please wait. Let me share the course flow as well as the textbook associated with this course. Yes. So the main objective of this course, this is about the course introduction, right? That is what you can expect from this course and what you cannot expect from this course, because since you have parallelly very good and mathematical courses are parallelly going on, right? Yes, I hope, right? So the objective or the main objective of this particular course is we will introduce the basic concepts and techniques of machine learning. That is, what is machine learning? That is very important. It's not like a definition. Actually, what exactly machine learning is, and when we are supposed to use the machine learning concept, and why we are supposed to use it, right? And all such information, the basic and foundation will be provided in the entire 16 context session, as well as at the end of the course, you can gain experience in basic of doing some independent research, like you can take your own data set, and according to your problem statement, you can analyze the data set. You have the capability to analyze, and you can adapt the most suitable machine learning algorithms to solve the problem statement, right? There are multiple machine learning approaches are available. Like each and every algorithm is efficient in one scenario, and it is not that much efficient in another scenario. It's purely based on your data, that is data set, right? So it depends on the input, what input you have in your hand. According to that only, we are supposed to adapt the machine learning algorithm. So at the end of the course, you can come to know about, okay, what would be the best suitable approach or best ML algorithm can be adapted for my data set in order to solve this objective or the task, right? So that is the main objective of this course, and you can develop your skills of using recent machine learning software tools, like latest tools can be introduced, right, to evaluate and learn the algorithms, right, and the model selection. That is what model selection is. Since there are multiple algorithms and models, what would be the feasible one to produce the best result? To compare, for that purpose, again, it's a trial and error. You have to, even though you have some common benchmarks, terminologies, and the conditions, right? You are supposed to do some trial and error as an analyst. You have to explore and you have to come up with, okay, this is what the best model for my data set according to this performance metrics or evaluation categories, right? So all such informations can be it will be explained in the throughout this entire course, right? These all are the main objective of your machine learning. Okay, and our focus is, don't worry, we will be providing a very strong mathematical foundation of ML algorithms, because just like that, because there are multiple algorithms, ML algorithms are available. Our focus and our intention is not like that, okay, what is what and where we have to adapt and what are all the applications, what is the disadvantages and advantages. along with that, the main important thing is the math behind each and every ML algorithm should be, it should be disseminated to the learners. That is what our main focus of this course, right? But don't worry, it's not that much mathematical course. It's not a mathematical course, but math is a backbone of your ML algorithm, right? So parallelly, you have some introduction to statistical and foundation of mathematical for machine learning and all. Some courses are parallelly running, right? I guess. Yes. So along with that, so all such courses are aligned with respect to our ML course only. So don't worry, you will be getting benefit, like you will get more knowledge with respect to the mathematical foundation for ML. All topics have been covered in that parallel course, as well as with respect to each and every ML algorithm, we will be also covering the math behind the backbone of each and every ML algorithm will be covered, right? So don't worry. And it's not like it's not like a content based approach, right? So the math and implementation all together, it's a combinations of a mathematical concept, content, as well as the programming, implementation part all together is called as ML, machine learning course. Okay. And our focus is about structured data analytics. What is structured and what is unstructured? That you should know and you should aware, right? Structure is nothing but if you have a proper structured data like tables and row, if you are able to convert your data into a number of rows and columns, that is called as tables, right? In general, technically we call it as tables in SQL, right? Structured query language. I hope you all aware. SQL is structured query language, meaning which the data are organized in a way, in such a way that like it's a structured approach, number of rows as well as number of columns, right? So if your data are organized or arranged in that manner, our focus is we are going to focus only about the structured data analytics, right? So your input will be always a structured data, especially in ML courses, right? For all algorithms. And what about this unstructured? Okay, fine. We'll talk about this later, right? And what is this independent and identically distributed data? Independent is nothing but each and every column is independent with other column, or independent with each and every record is independent of other record, right? And what is identically distributed data means, like if your data are, that is what IDD, or IDD is generally called as independent data, right? And one more thing is, if you have multiple columns in your data set, column 1, column 2, column 3, right? If you have multiple columns in your data set, each and every column values, for example, record 1, record 2, record 3, if you have five records, all 5 records values have been the distribution of data is based on, the data distribution is based on some mathematical approach. Identically, it should be distributed. It purely depends on the data distribution. So based on that data distribution, we consider that distribution alone, as well as we consider the structured data alone here, right? This is what our focus of the course. And what about topics not to be expected from this course? First one is unstructured data. So like, for example, it could be your input could be image, your input could be text, or your input could be a time series data like market, stock market prices or stock prices, right? Or it could be an audio file, or it could be a video file, right? All such data are called as unstructured data. That is not covered in this particular course, because it will be covered in the upcoming, like deep learning or some other courses will take care of it. Okay. And the time series and sequential data analytics and deep learning approaches. These all are not, these all are the topics which are not expected from this course. Our focus is only the mathematical foundation of each and every ML algorithm, the best and the benefits and the cons of, that is pros and cons of each and every ML algorithm, and the data set adapted here is it's a structured data set. So I stop here. Any queries? Yes, no queries, right? Yes, I understood. Krishna, yes, nowadays, see, even though the slides are not outdated, the thing is, uh, you should, first of all, you should know, or you should aware of the basic and foundation. Then only you can upgrade yourself. Without understanding the basic concept and foundational of each and foundation of ML algorithms, right, or the core concept behind ML, we cannot jump over that, right? So it's like everything will be technical jargon for you, right? So step by step, you should start learning. It's a learning. Yes. Yeah. So our module, the course plan would be the introduction, machine learning. In the first context session, I will explain about the introduction part of machine learning and the machine learning workflow and the linear model for regression and classification. These all are our course plan, which are available in your even in course handout as well, right? And you can refer these textbooks and reference books, right? The textbook would be Tom and Mitchell, the machine learning, the best book, right? And the references are R1, R2, R3. I have given 3 references here. You can refer with respect to evaluation scheme. As per the WLP division, you will be having 3 components. 3 mandatory components: evaluation component 1, EC1, EC2, right? And EC3. So these two, the quiz as well as the assignment will comes under EC1 component, right? Uh, I mean, with the weightage of 30 marks, right? And EC2 is your written exam, mid-semester exam. It's a closed book examination. The weightage of 30 marks, and EC3 comprehensive exam with weightage of, again, this is also written exam, but it's open book, right? The weightage of 40%. So altogether it is 100, right? So there will be 2 quizzes will be deployed. Out of 2, the best will be considered. The weightage would be 10%, right? And moving on to the assignment, again, there will be two assignments, right? 2 assignments, the weightage, the marks for these 2 assignments would be 20%. So 20 plus 30 altogether comes under EC1, right? And this is very, very important. There is no makeup for EC1 component, right? You should submit your assignment as well as you should attend your quiz as per the timeline given. All the EC1 related announcement and the tentative schedules, everything will be shared shortly before coming to the next contact session, right? Within 2 to 3 days, it will be shared in the announcement section. Okay. Yes. How many EC1s will be there before final exams? No. EC1 is, it's a component, right? The thing is, like, 2 quizzes will be, that is pre-mid semester, 1 quiz will be deployed, and post mid semester, 1 quiz will be deployed. Yes. And you should attend both the quiz. It's your wish, because best of 1 will be considered. And assignment also, post mid semester as well as pre mid semester, there are 2 assignments. So you are supposed to submit the assignment as per the deadline given. Okay. That is about your EC1 component. Yes. No. For quiz alone, best of 1. Assignment, both assignments are mandatory. Yeah, you can get the link from e-library. I'll check with the team and I'll let you know by next week. Okay. Yes. Right. So the prerequisite topics are like everything is maths again, right? Linear algebra, that is vector, what is scalar, the difference between vector and scalar, matrix representation of data, matrix manipulations and operations, and the properties of vector and matrix. All such informations or all such concepts comes under your linear algebra, and the calculus part, partial derivative, right? And the probability concept, common distributions, Bayes rule, conditional probability, all such terminologies you should aware, right? And moving on to the statistics concept, mean, median, mode, maximum likelihood, right? Everything is like your prerequisite. right? So the thing is, in school days or even in the college like UG, right, we have studied these mathematical concepts as a mandatory course in your very first semester or in the second semester, right? Without knowing and even without understanding where it exactly used, right? So the thing is, I just wanted to connect the dots, all mathematical topics with respect to your machine learning concepts, right? Machine learning algorithms. And moving on to the lab plan, we have six lab experiments, end-to-end machine learning, linear regression, and gradient descent algorithm. These all are the lab components, right? But labs are not graded here because your programming skill can be evaluated uh, through your assignment submission, right? And most of the lab recordings are available at CSI virtual labs. You can verify or you can refer, right? And we have 4 dedicated webinars for lab sessions, right? To demonstrate that our TAs will demonstrate these lab experiments, right? So labs will be conducted in Python. And one more important thing, I just wanted to know, is my screen is visible? Like eLearn portal? No? No. eLearn portal. Are you able to see my eLearn portal? Yes. Thank you. Yeah. So here, see, once you entered into this main page, you'll be having like my courses, e-library, and my virtual labs, right? So try to connect to the lab here, CSIS, right? Connect to lab. If you don't, if you're aware, if you're not aware, then please click here. The user manual will be available. Okay, user manual will be available, and how to connect and all, right? You can go and check. If you want to do your ML labs, you can click the ML lab will be mapped here, and you just after that you just book the slots and try to start. The cloud platform will be provided. Try to implement all your assignments and whatever is associated with this ML course. You are supposed to use this virtual lab setup. Okay, so if you have used Google Colab, no problem. You can use it here, right? So without this, if you have submitted the document, then it will not be considered for assignment evaluation. That you should aware. Okay. Try to explore. If you have any queries, we can resolve. I'll resolve it in the next class. Okay. Course handout will be available in the very first page of your e-learn. Okay. Yes. Yes, Rauri, you have raised your hand. Yes, Krishna.
Ma'am, thanks for explaining. Uh, I have one question in the prerequisite section. You mentioned about linear algebra, calculus, a few other topics. Can you please go back and read on the same slide? Just,
Okay, here.
yeah, this one. Probability and statistics are there. Okay.
Yeah.
Okay, thank you, ma'am.
Yeah. Yes. Shall I proceed?
Also, ma'am, the books that you have recommended, will that be available in the e-library? There is a reference library that we have, right?
Yeah. It will be available. Yeah. That is what I need to check once again, right? I'll check and I'll let you know. Otherwise, I'll give you how to get it. Okay.
Okay, ma'am. Thank you.
Yeah. Yes.
Ma'am, thank you.
Yeah.
This one quiz and one assignment before mid-sem exam and one quiz and one assignment after mid-sem exam. Is that correct, ma'am?
As of now, that is what the plan, right? Again, we have to discuss with the lead, learning facilitators as well as the lead instructor for this course, right? So don't worry. The detailed tentative, it's not like tentative, 90% that is your final schedule, right? So the schedule, quiz schedule, as well as the assignment schedule, when it is going to be rolled out and the submission date, deadline, everything will be announced shortly. Okay. But as of now, one quiz and one assignment before mid-semester and one quiz and one assignment after mid-semester. That is what as of now, that is the plan. Okay.
Great. Thank you. Thank you.
Yeah. Yes, I'll proceed. It's today's agenda. Yes. So it's almost 30 minutes over. I just wanted to dive into the today's plan, right? Yes. So these all are the topics I would like to cover today's in the very first introduction session. What is machine learning? Why we need machine learning? Why it is important, right? What are all the types of machine learnings are available and where we can use it, the real-time application areas, and if there are some technologies or new technologies comes into our life, like in the trends, like there should be some issues, right? How to overcome it and what are all the complexities or the issues associated with this machine learning, everything can be discussed by today's session, right? Yes. I hope you all heard about these terminologies: artificial intelligence, yes, data science, and ML. I hope you all heard about this, right? AI, ML, data science concepts and all, right? The thing is, I mean, can anyone explain, or can anyone give your suggestion or give your observation about all such terminologies? What is AI? What is data science? What is machine learning? What is your understanding here?
I guess AI is a umbrella term that is coined to cover all the
everyone can speak. Okay, everyone can speak now. Only for 5 to 10 minutes, right? After that okay. Yes, please.
My understanding is artificial intelligence is a term that is coined as an umbrella term. It is all the data science and machine learning, all that information, right? Related topics.
Okay, super. Yeah, artificial intelligence is actually, it's a very big domain and it's a very big terminology, right? That there we are trying to make our mission to mimic the thought process of human. It's an artificial intelligence, right? We are trying to make some intelligence, like I mean, whatever, it could be a mission or it could be a agent or whatever, right? If that mission or the system try to mimic the thought process or the behavior of or thinking or whatever, right? Mimics the human behavior or human thought process, then which is comes under artificial intelligence, right? Under this artificial intelligence only we will be having the machine learning concept, right? The data science is nothing but you will be having some data in real time. Whatever is posted, please mute yourself. Yeah. So, especially in real time, there are so much of data are generated or accumulated in each and every transaction or each and every post. If you have posted something in Instagram or Facebook or whatever, right, in any social media, if you have posted something or if you have written something, everything will be considered, or if you have given thumbs up, everything will be considered as a data. Yes? Do you agree with this?
Yes, ma'am.
Yeah. So every day in day-to-day life, we have generated each and every person separately or individually, we have generated so much of data, right? So from that data, if you want to take some decision, especially business perspective, right? So if you want to take some decision, if you want to take some with respect to business perspective, then which is comes under data science. There are lots and lots of collections of data are available, and based on that data, the analysis should start prepare the data for analytical, for analytical purpose. And after that, you can use or you can leverage AI ML concept, and you can utilize any one of the statistical approach to come up with the decision. That is data science, right? Artificial intelligence is nothing but if the machine mimics the thought process of human being, then it is artificial intelligence. And to understand and interpret and learn, make intelligent decision, right? Here the mission will try to make some intelligent decision, right? And what about this mission learning? It's a subset of AI, right? Artificial intelligence, right? So here there are multiple algorithms associated with mission learning, but what we are trying to do here is we want our mission to learn. I'm not going to give anything to you, right? The thing is, I'll give you only the data, right? With the help of that data, you have to, it is your responsibility. You have to start learn what is hidden in that data, or what pattern is associated with that data, right? Based on that analyzation, or based on that understanding, your mission should come up with one conclusion. Okay, this data can be categorized like this, or this data can be represented like this. Likewise, the mission should learn by its own, and then it should come up with a program that is called as mission learning. Okay, so these all are the difference between AI, data science versus ML, right? So what is ML, when it is supposed to use, and where we are supposed to use, right? Before going to start with the traditional, mission learning approach, I hope you all aware we have a traditional programming, right? So initially in the start, we will always maintain the data, or we have always maintained the record in notebooks and all, right? So what suppose if the complexity increases, we need help. We have taken help from computer. Simply, you will pass the input data, as well as you will write. As a programmer, we have to write the program. Yes. So as a programmer, we have to write the program, and in the program, if input and program is passed to the computer, what the computer will do, based on the input and based on the given code, it will execute the code and it will substitute the input. Finally, you will be getting output. This is the traditional programming approach. Yes. And what about mission learning? It's totally reverse process. It's nothing but, see, instead of giving program, what we are trying to do here is, I'm just going to give the input. Okay, just give me one answer. What suppose if I ask you to purchase one flat, or a flat in your location, what are all your consideration? Yes.
Price.
Square feet. Yes.
Square feet, yeah.
Yes. Square feet. Then
Price per
Price.
square feet.
yeah,
Immediate.
price. We can also have a price, and then
Localities.
whether it is residential area or not, whether the car parking is there or not.
Amenities,
Yes.
yeah. Mhm.
Yes.
Location.
Yeah, location. Location means like okay, like outer area, or that
Yeah.
that is what. Yeah, okay. Location,
Let's say,
whether it is
distance
within
from
city
the
limit or
hospital.
outside the city limit. Yes. Okay, that's it. Fine.
Distance, yeah.
Yeah, distance. The locations. The location is more than sufficient, right? Within city limit or outside the city limit or nearby your office or whatever. Okay, fine. Okay, these all are we will restrict. There are multiple constraints, right? We will restrict only with these input informations, right? Okay, yes. So out of this information, if I ask one person, you will give one information, right? Yes. I need
1,000
1100
square
square feet. Yeah, 1000 square feet. And it should be a residential area. I need a car parking, right? The price should be, okay, the price or the location is within city limit. Yes. So if all such informations are expected, obviously the price will be
Let's say once here.
High.
considerably high,
High.
because you are expecting the flats nearby within the city limit, right? So obviously it's higher. For example, just assume I have given $1,500. For example, just assume, right? If I have asked one more record, if I want to record one more data, right? For example, 800 square feet. I don't need residential area, right? But I need a car parking, right? But I don't need within the city limit, outside the city, right? Then obviously the price will be. Will you declare like $800 or $1,000?
Yes, around that.
Yes.
Less than 1,500.
Obviously less than 1,500. Please mute yourself. Yeah. Obviously less than 1,500, and I don't want residential area, right? Obviously it's outside the city, right? So most probably you can expect lesser amount. For example, $750. Likewise, we will be having some data. This is what your data. Will you agree this?
Yes.
Yeah. In this
Yes,
data, which one can be considered as input information and which can be your target or output?
Price is the output.
Price is the output, the rest
Yeah,
of them
price
input.
can be, it can be anything, but logically they will consider, we want to predict the price. What suppose if I want 2000 square feet flat in a residential area and I need, along with that, I need a car parking, right? And within the city limit, then what would be my price? What would be the flat price? That is, that I can do it, right? Yes. I can expect no. Yes. Along with this data can be categorized or subdivided into input and target. Here the inputs are input features. Inputs are nothing but we can call it as features or independent variables, right? Feature 1, feature 2, feature 3, right? These all are features, but these all are input features, right? And this is what my output or target variable, right? So the thing is, along with,
excuse me,
please,
ma'am, but
please hold. Let me explain the concept first, and I'll ask you if you have any queries, please raise your query that time alone. Okay. Otherwise, it's a recorded session. No, there will be too much of interaction is not allowed here, right? One second. So feature 1, feature 2 up to input feature 4, all will be considered as your input data. And what could be considered as your output? The price. Yes. So along with this input, and I have mapped, see, for each and every input, one target or one output is associated. Yes. So if you know for sure about these informations, that like past, based on your past previous historical data, like past 2 years data, if you have such information, you can pass those information to the computer. What the computer will do, it will, that is the machine learning, right? The the mission or the model will try to identify the hidden pattern of this data set, right? And it will come to one trained model. And if I have passed one unknown data, for example, 900 square feet information or a 900 square feet flat, and residential is yes, and car parking is yes, and the location is city limit. If I have passed these information, input information to check my model, right? This is a trained model. This program is nothing but the trained model. So in the trained model, if you have given this data, then the trained model will give you the output. For example, 950 or 1000 square feet, because this the 1000 square feet is not typically based on some rule system. It will try to understand the pattern behind this data set. This is called as exactly machine learning. This is what your machine learning will do here. Okay. So the technical terminology or the formal definition would be a well-defined learning task, because the model or the machine will try to learn the pattern. That is why hence it is called as machine learning, right? A well-defined learning task is given by PTE, right? We will talk about these three terminology in the next slide. Okay. Yes. Any queries?
Yeah, ma'am. So basically, let's say when we are training the model, we'll also decide to configure the weightage of F1, F2, F3, right?
Yeah. So no, please. Yeah, that is the next context out of scope as per today's context session. We
Okay.
should assign the weightage. That is linear regression concept. Don't worry, since it is a very first class and introduction class, right? I just wanted to introduce the terminologies, because you might be aware of what is machine learning. You can know about the different terminologies as well as the different algorithms and all. But I mean, we
Yeah.
have
All right,
different
ma'am.
levels of people in the class, right? So I
Yeah.
should start from the scratch. Okay.
Yeah.
Don't worry.
Ma'am,
Everything will
also
be
one more
covered in the,
question. Yeah.
yes.
Onto the previous slide, right? Where you explained about data science and yeah. So let's say the objective is to get insights from the data. Like
Yes.
the we have artificial intelligence and machine learning. What are the other ways to get insights from the data?
Insights.
Yeah, I mean,
Okay.
from data we are getting to a decision, right? Like we are trying to
Decision. Yeah.
get
You have,
insights from the data.
insights, like that is called. For that, we can use the visualization, we can use the statistical approach to get in. You want to give some observation about your data, right?
Yeah.
Okay, this is what my data is. That is what your expectation, right? So you want to
Yeah.
tell the end user, okay, this is what my data is. So you can give more discount for this particular product. So that decision can be taken during this data exploratory analysis, EDA process.
Okay.
Okay. Yes.
Thank you, ma'am.
Yeah. So the next thing
Ma'am,
is,
I have one query. Right? Yeah. So
yes,
there
yes.
could be any multiple permutation combination for input data, right? So suppose, for example, price could be an input data if I have a already decided budget, right?
Okay, it could be anything. That is what it could be anything. That the thing is, if you have considered price, you can check, okay, for this particular price, how much square foot I can expect. It's your wish. It's not necessary that one particular column should be always a target column. It's your wish. You can make, that is what, according to the problem statement and according to the objective, you have to fix your input and you have to fix your target. It
Yeah,
depends on the
understood.
problem statement.
Yeah, understood, ma'am. Thanks.
Yeah. Yeah. So the next discussion is about formally we can, we can use the terminologies called task. We want to improve the task, whether it is a price prediction or if you want to classify whether it is the male or female or whatever. Your task can be anything, right? If you want to improve the task with respect to performance, how do I know I need to improve the performance? I need to improve the task or improve the efficiency of the model based on some performance metrics only. We can come up with one conclusion, right? And based on the experience. So the task here is, for example, just assume I have some handwritten images. Just consider all are images, right? I can write two like this, or another person can write two like this, right? Or like this. So you can have a different style of writing for to represent number two alone, right? So just consider this is image 1, image 2, and image 3. And I have these many images, like starting from 0 to 9. Okay, these many images. So hence there are 9 categories are there. The first category is 0. The last category is 9. 0 to 9. So our task here is we want to recognize, that is, we want to recognize the handwritten word, whether it is 0, whether this is 0 or 2, or it is 1 or 2, 3, 4, 5, 6, 7, or 8 or 9. It could be anything. So based on the pattern associated with this particular image, we want to recognize this handwritten words, right? That is what my task here. And percentage of words correctly classified. So how do I know whether my model performs well, behaves well? Suppose if you have 10 records, right? Just assume if you have 10 images, out of 10 images, 8 images were properly classified. Only 2 errors. That is percentage of words correctly classified. That is what percentage, right? Or performance, right? So that is accuracy. How accurate my model is can be represented using a performance matrix called P. This performance matrix, which can be varied from one scenario to another scenario, right? And what about E here? The database. This is what your input, that is experience, where I can get such all handwritten notes or handwritten words. Everything can be stored into that database of database of human labeled images of handwritten words. So from the database, we can get it all the input informations and we can perform the task, right? This is the definition of learning task. And I have given one more example here. If you want to categorize the email, whether it is spam email or legitimate email, right? We can do it, right? Right? So that is what our task. So the percentage would be the performance would be the percentage of email message correctly classified, and the experience is based on the past previous collection of emails, right? With some human given label. This is what very, very important, right? labeled images. That is, as a human in the experience or in the based on our past previous experience, I should represent, okay, this is nothing but 0. This is labeled image, right? This is input image and this is a target. That is 0 this is nothing but this represents 0. And what suppose if I have written like this, what is this? It's 1. This is called as labeled images. So input associated with the output or target variable is called as label. Okay. So in this case, what suppose if you have some content or subject line here, it can be classified as spam. For this subject line, it can be a legitimate mail, right? Likewise, we should have some input and output mapping. That is technically called as labeled data. What is labeled data? For the input, if you have corresponding output, then it is called as labeled data. Got it? Yes. So we can have more examples like this. Playing checkers, you just check this, and drive in public 4-lane highways using a vision sensor, right? This is my task, and you can take an average distance traveled before an error, right? It can be just by the human, and the experience can be a sequence of images and steering commands recorded while observing a human driver, right? So the human driver should observe each and every action taken by the self-autonomous car. So this is called as this is the proper definition of learning task. I have given three to four examples here. Okay, and the next important thing is the traditional. I just wanted to give you the difference between traditional approach as well as the machine learning approach. In traditional way, how do you classify whether if you have 10 emails, email 1 to email 10, right? So how do I know whether this email is spam or not? I have given only
some
very
keywords
lesser
basically.
yeah, based on some
We can-
keywords.
Yes,
Yes, please.
Identify some keywords.
Yeah,
Red flags.
based on some keywords, like for example, you have when the lottery prize 1 crore or 1 lakh or credit card free, right? These all are the keywords. Amazing prizes are awaiting, right? Likewise, if you have some headlines or a subject line, right? Based on the keywords, what I can do, I can collect the suspicious keywords into one corpus, that is in one database, right? If these words are available in the subject line, simply it's a rule, right? It's a rule-based engine, yes or no? So we are trying to detect the algorithm for frequently appearing pattern in a spams, right? So, and then simply just test and update the detection rule until it is good enough. It's very, very simple. Study the problem statement accordingly based on the keywords available as of now. Just write the rules and evaluate whether just pass the E1 to E10. Just evaluate whether this rule engine or whether this rule or the traditional approach detection algorithm properly classified each and every email as a spam or not. Yes, even to E10, right? So this is general approach. What suppose if it is not up to the level, again we have to, if more errors are encountered, again you have to again go back to the problem statement, rewrite the rule as per the given, based on the error observed. Again, you have to do it again and again until you reaches your more appropriate decision. This is a traditional approach, right? So as a human or as a programmer, I have to write the rule. It is my responsibility to come up with the best combinations of rules. Okay. But in machine learning, it's totally different, right? Give the problems, just analyze the problem statement, give the input data, train ML model, just give data. Data consists of both input and output. It's a labeled data, right? Both input and output data based on the past previous collections of information. I have passed such information to the model. The model will try to identify the pattern. Okay, if these words are associated in the subject line, according to the past previous experience, the human labeled information is spam, right? So likewise, it will try to identify the similar patterns or the patterns associated with the spam email as well as the pattern associated with the ham email. And then it will try to come up with one trained model. Okay, one trained model. So now you can evaluate the solution, launch the model or deploy the model. So if it is good, right? What suppose if you have errors, then you can go and analyze the error, try to retrain the model by adjusting some values and by adjusting, there are multiple techniques are available to come up with the best solution. Okay. So this program is much shorter, easier to maintain because we don't need to write any rules and all because the rule will vary if your data is changed. Will you agree this? So initially you have a database with respect to only 10 emails. Based on the 10 emails, you have identified some suspicious keywords, and based on those keywords only, you as a programmer, as a human, we will write some rules. Yes. What suppose if I have added what suppose if I have added 1,000 emails along with this existing 10, right? So it's a hectic process for a programmer to understand the hidden or to understand the suspicious words. What suppose along with, see, for 10 emails alone, you will be getting, for example, 10 words, 10 suspicious words, right? Or for 1,000 emails, the number of suspicious words will be more. So it's our responsibility. We have to come up with a very complex rule structure. It's not feasible at all, right? If the input size increases, this traditional approach will not work, and even you will not get the proper result. So that is why we moved on to the ML approach. So even though you can have 10 datas or 1,000 datas or 10,000 datas, right? So based on the data passed here, the model will try to learn the hidden pattern and then it will finally evaluate it. This is a traditional, this is the difference between traditional approach and ML approach. Okay, so the thing is automatically learn, that is learning can be performed automatically, right? So if you have passed the data, right, to the training model, to train ML model and evaluate the solution and launch the model. If you want to update the data, see, initially you have 500 records, and if you are interested to update one more, 500 more data here, and after that you have to pass all 1,000 records to train the model. This process will be automated, right? So you don't need to write the separate rule again and again based on the updated information. It's not necessary compared to the traditional. This is very, very easiest way to come up with the solution, right? Yes, that is about your introduction, and now we will move on to the application part, right? So with respect to applications, okay, it's question for you. Where we have used this ML approaches?
Autonomous car driving.
Car drivings, okay. Self-autonomous car. Are you talking about self-autonomous car?
Yes, ma'am.
Okay, fine. Then,
Google Maps and all.
sorry, Google Maps. Can you please mute yourself? Too much of noise. Sorry. Yeah.
Number
Sentimental
plate
analysis,
recognition.
classifications.
IRCTC for seat confirmation.
Sorry.
Image
IRC
forensics.
IRCTC, railway ticket booking, seat confirmation probability.
Weather
Confirmation.
forecasting.
Weather forecasting. Stock
Claim
price
denial
prediction.
classification.
Shopping
Sorry?
recommendations. Vehicle number
Shopping.
plate
See, in
recognition.
day-to-day life, we will be getting some recommendation from Swiggy, Uber, and all, right?
Claim denial prediction.
Yeah.
Movie
Yes.
recommendation.
YouTube search.
Delay prediction. Yes.
Traffic violation prediction.
Traffic violation.
Yeah,
We
traffic
can also
violation.
predict traffic. We can expect the traffic. Like for example, see, if there are some political rally, or if it is a festive season, or if it is a rainy season, or if it is a weekend, obviously we can expect traffic in one particular location. We can predict the traffic as well, right? Yes. So all, see, it's not necessary. There is, we cannot restrict the ML with one particular domain. Yes or no? Whether my claim is true or false.
Yes. True.
Whether ML can be adapted only for medical, or only for education side?
No.
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 Can
We
be
can
applied
adapt,
anywhere, right?
yeah, anywhere. We can adapt the ML model in with respect to medical image field or finance, banking, or a mechanical domain like manufacturing unit. In the manufacturing unit, we can predict the lifetime of the the machineries and all, right? So based on the errors, based on the recorded information, we can predict it. Even in the logistic, we can use it. Even we can use it in the education field or the colleges or university. We can predict the admissions in the upcoming year based on the current placement and based on the current student behavior, right? Or the advertisement given in the social media, or we can predict even the election result, or we can predict the weather report or stock price, gold price. Everywhere we used or we adapted the machine learning approaches or prediction or ML algorithms. Yes or no?
Yes, ma'am.
Yeah.
Yes, ma'am.
So one such applications are like Siri or the object categorization. See, this agent can categorize, okay, whether this is ball, right? Whether this is ball or bat. Likewise, the machine has the ability to categorize the objects. That is object categorization, or the agent can predict, or the model can predict some values. Even with the help of X-ray images, it's not comes under your. It's in deep learning. So if your input is image, then you are supposed to adapt the deep learning, right? But still, right? We can instead of X-ray images, what suppose if you have converted all such informations into a CSV file, then you can use the medical diagnosis, right? Yes. Yes. So the next thing is the transaction analysis, whether the credit card fraud detection and all, we can do it. And even the recommendation system or in the text processing, the Google Translate from one language to another language, speech recognition system, everything comes under this domain only, right? So the thing is, with respect to planning, you can use navigation, pathfinding robot, gaming, controlling. Yes. And with respect to problem solving, if you want to detect the pattern recognition, like this, see here. I mean, so based on the curve, based on the visual representation, where it is, this is what the peaker curve, peak here. This is according to this. This would be your peak, and this would be your drop. Yes, likewise, we can have some decision. We can take some observation from the information or observation from the visual representation. We can detect the pattern so that, okay, in the next week, the stock price will increase or decrease. Likewise, we can come up with one conclusion. Even you can also use the optimization for decision system, right? These all are the common applications or use cases. Don't worry, in each and every ML algorithm in the upcoming classes, I'll take one real world case study. I'll try to explain the case study, and then we will move on to the context. Okay. Yes. So this is about the applications in all smartphones and the transportation optimization or popular web services, right? And the e-commerce web services or sales and marketing, security, financial, in all domains, we can use the machine learning. We can adapt to the machine learning concept, right? And see here, this is about what is okay. By seeing these three images, what is your understanding? Image 1 tells what? Image 2, image 3.
Image one, sorry.
Ma'am, could you please tell me what's the use case in the mobile application of ML?
Mobile applications like
In previous slide, you have mentioned application
in
smartphones basically.
yes,
So what's the use case of ML over application smartphones?
like so like see, we can use some optimization, right? The device or the app optimize. All optimization comes under this ML only.
Memory usage.
Memory usage, yes. That is, it will predict.
Optimize
Yeah.
map path. Maps path, optimize maps path.
Yes.
The way I understand is in iPhone, usually they track the screen time and also the amount of time that you spent in the sleep. Then it will use it for the health data in order to understand how
Yeah.
much quality of sleep that you have got and whether you are. It will
But I
also
believe
track
that,
how. Yeah.
sorry to interrupt, but I believe that machine learning is for the basically for the prediction basically. So
Mm.
Not
what
only
actually
for
we are,
prediction. No, 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 no. No.
okay,
It's not like that. It's not only for only price prediction, stock prediction, or categorization. Yes, there are multiple tasks associated with machine learning. So first, okay, that is what I don't want to touch too much about this application point of view, because after understanding what is there in the machine learning, then only you can connect the dots, right? Even the
sure,
face
ma'am, sure.
unlock, that is the face unlock, the fingerprint, voice assistant. You can enhance the camera, right? WhatsApp, it's
Got it.
very simple. Even in
Got
the
it.
WhatsApp, if you have typed something automatically, or the next suggestion, the next word would be suggested, right?
Yes, exactly. In the YouTube as well, like we used to
Yeah,
get the
in
recommended
YouTube, you are in,
videos.
yeah, the recommendations. And see, whatever we used in the web, everything can be adapted in a smartphone also, right?
Thank you
Yeah,
so much,
health,
ma'am. Thank you so much.
health and fitness tracking, everything is comes under what, the machine learning approach only. Okay. See,
So,
it's
ma'am,
very
it's
simple.
a
ML
the
detects
machine.
unusual login activity as well, the malwares and suspicious app behavior, right? See, what suppose it's simple. If you have typed good alone, right, automatically your phone may suggest morning or evening according to that. Yes, good morning or good evening. Hi. The subsequent word can be suggested. The word recommendation can be provided. It can be provided, right? All such or comes under your application parts of ML only. Yes. Yes. So in this slide, what is your observation? That is what my question. I have given 3 slides, right? First one is like it depends on what scenario behind this.
First one is like, okay, for mobile, like, okay, how we are
For
deciding.
mobile,
Yeah,
Is it
performance,
is it traffic
design, theme.
prediction?
Okay,
Just
first
route.
one is okay.
first one is related to design and yeah, update, price, service, and performance, right? So mostly like, okay, that will be for, yeah, and GPS. So
Yes,
we
of course,
can,
of course.
yeah,
Yeah. Based on this input itself, you have come up one conclusion like, okay, this is like a sentiment analysis of mobile phone reviews. Yes.
yes,
Yes. So these blue color represents positive review and red is negative and green is neutral. What is this value represents here? 107 positive reviews and 17 negative reviews and 0 neutral with respect to performance. And moving on to the battery, only 1 positive review, 1 negative review, 0 neutral, right? So what ML does here? So it simply reads the customer reviews as a text data, right? And what it will do, it will classify them into 3 categories. Either it could be a positive, even you can come up with only 2 categorization, positive, negative alone. It's not necessary that you should use neutral, right? So if you want, you can add one more category, right? You can categorize the reviews. That is what your target. So based on the performance, value, design, and theme, and weather, clock, update, price, service, battery usage, and everything, we can, I mean, if I have given one more text sentence like this, the model will try to predict, okay, this sentence comes under, or this review comes under positive or negative or neutral, right? So which helps the companies to understand the customer satisfaction and the product issues and the improvement areas as well, right? So if many users complain about the battery, the ML highlights the problem. See here, the privacy. Are you able to see here? Yes. So here the main issue is privacy, the security. Okay. And moving on to the second one, self-driving car. This is self-driving car. Yes.
there is nothing.
Yeah. So it's nothing but like, but this is what your actual input, actual viewable input or road, right? This is the segmented information. That is based on this, the model segment something. This can be segmented, right? ML identify whether it is road or what about this? This is vehicle. right? It will try to identify or classify, okay, now this particular route or this particular path is road and this is vehicle, right? This is pedestrian or traffic signs, traffic signals and traffic signs, right? So this is comes under use case of computer vision. What the ML will do here is it processes the camera input in real time, okay, which can be helped. I mean, which helps in lane detection or obstacle avoidance, obstacle detection, right? So the autonomous driving or the autonomous car can take a decision whether I have to I mean, increase the speed or take left or take right or move forward. So such decision can be taken here. Yes. And moving on to the right hand side, like it's, what is this?
ETA time of arrival.
Sorry?
Estimated time of arrival.
Maps.
Yeah, it's estimated time of the travel. It's like a map, right? What is that? Yeah.
That's basically navigation on the mobile.
Navigation, yeah.
Navigation or route,
Navigation
right?
in the mobile. So automatically what the mobile, I mean the Google Map will do here, it will try to suggest multiple route. So if what suppose if there are too much of traffic, it represents using some different color coding, right, to represent whether it is normal traffic or heavy traffic. Yes. So all such use cases are comes under. That is the thing is it's not necessary that it should be. We cannot restrict. That is what we cannot restrict the domain as well as the object or task for machine learning. We can adapt the machine learning, but the thing is you have to properly come up with one problem statement and objectives. Here, yes.
Sorry,
What about this
ma'am.
one? See,
Ma'am, can you-
ML. Yes, please.
Sorry, can you please go back to the previous screen now? In the first image, we have a summary which says on the top 4343, right?
Sorry.
And on the first image, the
Okay.
number 1 image, you have a summary on the top which says
Yes.
43 positives and 4 negatives and 3 neutral.
Yes.
That is
Yes.
something that has been inferred by the
No.
machine
This
learning.
is. I just wanted to test this mobile
test it.
product. Yes, I wanted. These all are my
It's the input.
training data. Yeah, I just wanted to test whether it is comes under whether the see the thing is it's not necessary that actually the target is positive, negative, neutral. If you want to check whether the review 1 or review 2, the content is a positive content or the content is negative content, you can do it. That is sentiment analysis. Okay. So it depends on the products and depends on the features. Like it can be everything can be comes under one particular model, right? Mobile phone model 1, for example, right? It could be for example iPhone M1, iPhone M1, right? So the reviewer given the performance, review for performance, review for design, how many of out of some 100 or 120, 107 have given the positive review for performance and 17 have given negative review, 0 have given neutral. With respect to design, it's not, again, one more thing, it's not necessary that all should be, I mean, all count should be equal. Because I can give only, because whenever we are trying to take a survey, we will skip some questions, right?
Correct.
Yeah, that is why you are getting the different values here. Okay.
Got it, ma'am. Okay, thank you. Please continue.
Ma'am, quick question, right? I was just trying to connect the dots over here. So, for example, in one of the previous slide, you represented that machine learning model would basically require data and output, and then it will produce a program, right?
Labeled data, yes.
Yeah, labeled data. So basically, let's say, for example, in this case, we are getting a labeled data wherein a customer puts a review and rates the
Review 1, review 2, review 3.
yeah.
This is positive, positive, negative.
Yeah,
Likewise,
and
if you
puts
have
and puts a
thousands,
rating over here also. Like for example, it's a 1-star rating. So the model could
what would be the
like,
review?
yeah. So it can basically infer that okay, it's a 1-star and the problem is with the battery. So it can like it has the input. But let's say for example, the other use case which we were discussing about the email, right? The spam or not. So in that case, how would we basically provide the model with that much data of 10,000 emails? How would we say that, okay, this was an spam, this was not an spam? How would we do that?
Okay, for spam classification.
Yeah.
Yes. Okay, I'll give you the, okay, you want to know about the features of spam classification, right? Am I right?
No, I mean, see, in this case, with the star rating of the reviews, we already have the output. That
Okay.
output was 1 star or output was 2 star, and the input was battery is not good or whatever the review is. Okay, so we have both the aspects. If you go back to the previous slide once
Okay.
where you explained that.
Okay, your question is, how do I know whether this information is spam or not? Yes?
How do I prepare that much of data set?
No. That is what. You can train based on the available historical information. So from the repository, you can download the spam related, this related data set. This is SMS spam or email. If you want to check the email, there are multiple open repository, free repositories or open sources are available, right? You just, you can train your model based on this. See here, this is what they have, some subjects alone.
Okay.
Right? And you have a label as well. This is labeled data set. Yes. Okay, but if you want to create your own data set, it is with domain understanding only you can do it, and you have to you have to get approval for that data set as well. These all are approved data set, right? If you are using this data set, it's quite fine because all are approved and all are evaluated one. Okay, manually evaluated, manually, even in the MNIST data sets are manually annotated data. One human, I mean, the human team involved in that for labeling purpose, right? So if you don't know about the characteristics of one or two, right? If you don't know about the numbers at all, then how do I classify that? So for that, each and every problem statement first and try to get some domain knowledge and then proceed. If you have a pre-recorded data or the historical data, then no issues on that. If what suppose in future, if you want to prepare your own data set based on the, if you want to track or if you want to get some live feed and all, you should have one help. I mean, you can take help from the domain expert to conclude or to evaluate.
So, ma'am, let's say, for example, this is like a simple example, right? But let's say, for example, if we are evaluating customers for loan default, okay, then in that case, for example, this is the data of a customer, and in this case, the intent of the customer was not there, and he defaulted the loan. So basically, all that data set, a customer or needs to, like, a user needs to prepare that data set. Is it like intentionally prepare that data set?
Yes.
Okay. Okay. All right. Thank you.
With respect to objective, they have intentionally prepared the data set. Yes. Okay. There are multiple applications. Please refer. Okay. And okay, if you want 5 minutes break, you can take. Otherwise, I will proceed. Need break? Yes, sir.
Yes, ma'am.
Okay,
5
just 5
minutes
minutes.
break.
Yeah, please, 5 minutes.
Can I have one question? I do have one query.
Yes, please.
On Kaggle, you have shown the data like of spam and ham over there. So I believe that that's I would say that's a biased data, like 70%. So how we should train our model on something which should not be biased data. So how we
Yes,
can
that is
reduce to
why.
Mhm.
That is why in the very first step itself, just like that, we will not pass the data to the model to learn. Yes, we should prepare the data. That is, it should be a more potential, and that is what you have to check. Is there any duplicates or there or not? Null values or missing values are there or not? Likewise, you have to do a lot of sanity check. Then only you can finally you will do some pre-processing and all. After that, that is what, it's a part of our syllabus. Don't worry, right? After that only we will try to give you, see, these these slides are a well organized and well prepared PPTs, right? What suppose if I have prepared partially, will you accept this? No, right?
Yes,
Yes.
exactly. No.
Yeah, exactly. Because I have to prepare the PPTs and align. I mean, it should be aligned with our syllabus. Just like that, I can't take a content from any other AI platform and all. I can't paste it here over here, right? It should be aligned with our textbook. It should be aligned with our reference book, and then only I can come up with this PPT, right? I can conclude this. So this is what the final data or final PPT for learning purpose. This can be forwarded to the student, not the draft version. Yes.
Got it, ma'am. Got it.
Yeah. So
Thank you so
whatever
much.
you are having, whatever is having in your hand initially, it's everything is like a draft version. As an analyst or as a ML engineer, you have to make your data for, I mean, it should be, I mean, we have to prepare the data. It's not like making, we should prepare the data for modeling. Okay.
Okay, ma'am.
Yeah.
I have another question. So,
For
which
5
machine
minutes
learning
break is for
models?
you only, not for me.
Yeah. Can I
Please,
proceed,
please.
ma'am?
No, please.
Okay.
Please
So,
proceed.
ma'am, like which machine learning models, they find out the pattern through mathematical, which is being used in that. And once the pattern is being, it got the pattern and it use it for prediction. So, is it right?
Yes.
So, how
It will
those
try to identify the similar pattern. Yeah, that is what our remaining 15 session content. How the machine understand the patterns and what would be the pattern for this particular task, how the pattern differs from one objective to another objective, right?
Okay.
See, it's very simple. Even in the previous example, like house price prediction, right? If the location is within the city limit, if it is residential area, it's understood based on some domain understanding. Obviously, you have given higher price. Yes or no?
Yes.
That is the pattern. It will try to identify, it will try to match the pattern. Okay, the first record and second records are similar. Like, for example, both are comes under within the city limit and within the, I mean, they expect, the input is residential area and even the square feet is nearby 1,000. 900 or 950 or 1,100, nearby 1,000 or in and around 1,000 or 1,100, right? So obviously, if you get the same input in near future, what the model will do? It will try to whatever is available in the target variable, the price, right? It will try to match the same price. It will try to provide the somewhat similar prices. Yes.
Yes.
That is called pattern identification.
Okay. And each model uses a specific mathematical calculation.
Yeah, that is what. How the pattern is identified, we need to take help from maths.
Okay, ma'am.
So, ma'am, I missed to ask that question earlier. There's a lot of like the mathematics is overwhelming. Like, how much of that needs to be covered? Like, is there no depth or basics is fine, or what's the depth we are talking over here?
The depth level is like, okay, you are expecting what can be done in our live session or for your reference or for your self-learning, or are you asking?
Both.
Okay, so with respect to live class and to cover the syllabus, the maximum depth can be covered because without understanding the math, if just like that, if you have implemented the concept, because everything is already the predefined libraries are there, right? Just by simply calling the method, you can run the algorithms and you can get it everywhere, get the result and all. But what suppose if I ask you to improve the model? What is I mean, if you want to check what issues are there in your model or after evaluation, even though the accuracies and some performance metrics are associated with each and every algorithm, right? If you want to fine tune your model, you should know about the math. So Up to that level, up to that extent, we have explained. Okay.
All
And
right,
ma'am,
ma'am.
do we also learn how to build our own model?
Sorry, how to build?
Sorry, I mean, how to build our own machine learning model, like using our custom mathematical operation.
Custom mathematical operation. You want to design your own new ML model.
Yes. Yeah, I mean, do we learn that, yeah? In this?
No, I'm not sure. Like, let's
Model
first.
can be achieved, but I don't know about algorithm. Is it possible to have our own custom algorithm, ma'am? Or
No,
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 I-
no, no. For that, you should, it's like a research, right?
And ma'am, like whatever mathematical topic which shown in at starting, like calculus, statistics, and these all. So if we have a good grip in that, can we able to design our own uh, model?
Yes, of course. But the thing is, the evaluation and you should, I mean, you have to come up with a novelty, right? That is very important. And your model should explain the, it should be competitive with other models and all.
Okay.
I don't want to demotivate you, but it's a research field, right?
Yeah.
Yeah.
So
You
my
can start
main
from now. That is what you can start from now. After completion of your MTech, you can proceed with PhD, right? You can come up with your own, with your name, right? Vivek Verma. You can come up
Sure.
like name base. You can also come up with one model. Yes, it's possible. Nothing is impossible, but it's possible. It takes time. Not within the 16 contact session or within this semester.
Okay, ma'am.
Just a suggestion for Vivek. Instead of building a new machine learning model, you can build your like own LLM based on the
Yes.
transformer or something else. That would be fruitful more than that building in a machine
Yes.
learning model.
Yeah,
See, the
first I
thing
will
is,
learn.
it's not necessary. I just wanted to tell you one thing. That see, even though you people are nowadays working with the LLMs and the generative AI, the prompt engineering, yes, but the foundation is ML only. Please understand. Without understanding this, without understanding you, okay, fine, you can proceed. But this is the proper flow. ML, DL, LLM, that is NLP domain. From DL, you can categorize like if your interest is text related information, you can go ahead with the NLP and then try to start learn about NLP and then LLMs, large language models, and then generative AIs, and then go on, right? Or if your interest is computer vision, like image related data set, go to the computer vision, and then likewise you can proceed. This is the proper path, okay? Because nowadays you have lots of AI to teach you. Yes.
Yes.
Yeah, ma'am,
Yes.
one question. The prerequisite mathematics you have mentioned at the beginning of this class. We had one
Yes.
bridge course like a few days ago, just to bring us up to speed on some of these calculus and things like that. But will that be sufficient, or because we need to practice that as well, right? So in this course, will we have that mathematical? Of course, there
Okay,
is a statistical.
I'll do one thing, right? So before starting, I mean, first two context sessions are introduction only, right? And it's not like introduction and foundation concept only I'll teach you, right? So from context session 3 onwards, we will start to learn about the models, right? Before going to start each and every model, I'll recommend these all are the prerequisite. It's not new to you, but you should refresh the topic like vector, matrix concept, right? It's not necessary that you should solve the matrix with proper derivation, like as you solved in your mathematical class. I don't want to, I mean, it's not necessary that we are supposed to implement. It's like we are supposed to, you don't need to solve, like find the determiner and all, right? But you should know what is the terminology and what is happening there.
Got it.
Up to that
Concept
level is more
wise.
than sufficient, so that whatever is explained in the class, you can connect easily. Otherwise,
Got it.
everything will be blank.
Yeah, going above the
Yeah.
head. Yeah, sure.
Yes.
All right.
Yes.
Thanks.
So I'll do that. Before going to start the machine learning models, in the previous class itself, I'll recommend some prerequisite topics so that you can start refreshing the topics. Now, then it will be easy for you in the understanding in the live session, right? Okay, the next discussion is about why machine learning, right? Why we need machine learning? See, whenever the human expertise does not exist, especially navigation on Mars, right? This is one of the example, and humans cannot explain their expertise, like especially in the biometrics or face recognition, right? So in the complex field, instead of using human expertise, simply use machine expertise. That is where we need a machine learning, right? So the model must be customized. That is, if you want to provide the customized or personalized medicine in healthcare, you can use machine learning, right? Right. So learning isn't always useful. So there is no need to learn to calculate payroll. We don't need to calculate. See, instead of calculating payroll manually, we can simply give the input and all to the model. Let the model will try. Let the machine will. Let the machine will learn. Right. So that is the concept behind this. And why only machine learning? That is very important. I hope it's already discussed, right? So some tasks cannot be defined well. For example, like it's very hard to write a program, even in the spam or a ham filtering, right? So if you have more number of suspicious words, if the number of records are increasing in nature, right? The writing a simple if-else rules is not sufficient. Okay, especially even for recognizing handwritten digit, right? Whether it is 2 or 7, how does our brain will do? That should be mimicked by your mission. It should understand, okay, if you have curve like this, if you have this horizontal line like this, then it should be 2. Or if you have one horizontal line and one curve like this, or one horizontal line or one vertical line, this is the pattern, right? So the model will try to identify the hidden relationship and correlation in the data. These all are technical terminologies. I'll explain what is each and every terms represent or associated with respect to your problem statement and all, right? So that's all about the pattern recognition. It's very, very important topic, which is nothing but types of ML. Okay. So machine learning is nothing but by sending or by forwarding the labeled data or unlabeled data. It could be anything, right? But I just wanted to forward the data. Data is nothing but past previous experiences, right? So how, as a human, how will you learn? They will learn by experience, right? If I ask you to learn swimming, or if I ask you to learn cricket, or if I ask you to learn any other activity, by day you will start to learn something new, and then at the end you will be pro in that particular domain, right? So this is how as a human we will learn, how the machine will learn. For that, we should provide the past previous historical data as an input. So based on that, the machine will try to learn something. It will try to learn the hidden patterns, right? There are actually 4 machine learning types of machine learnings are available. One is supervised learning. The second one is unsupervised learning, and the third is semi-supervised, but ignore it, right? It's semi-supervised is combination of supervised and unsupervised. And the third one is reinforcement learning. I'll start with supervised learning approach. Okay. Yes. So what is supervised learning? It's very simple. If you have handwritten record like this, for example, image 1 is 0, image 2 is 2, image 3 is 4, image 4 is 5. Likewise, if you have images, right, this is what my input X, and my labeled or target is nothing but, what is this? 0. The labeling, the manual label is 0, and this is 2, and this is 4, and this is 5. This is what my actual data, right? So in your data set, or if your input is consist of both input as well as the labeled information, right? Then it is you're in supervised learning, because I know the input as well as the corresponding output as well, right? So in my hand, I have both input and the corresponding output, that is 0 to 0. This is nothing but this is represents or mapped to 2. This information is mapped to 4. This information is mapped to 5. Under some supervision, if you are trying to learn something, that is, if you have a labeled data, then you are in supervised learning approach. Yes. Then what is unsupervised learning? See here, I have these many shapes here, right? Yes. For example, this is, or okay, you can consider color. You have some different shapes, right? All together, these all are red colored coins, or orange colored coins, or yellow color, green color, right? For each and every coin, this coin one represented by red. This is also represented by red. This is what labeled information. Along with the coin, if you have a color of the coin that is white, then it is called as supervised learning. And what about unsupervised learning? We don't have the color or the shape. It could be shape. The target could be shape or color, right? Yes, in this case. Yes. If you have like this, then it is circle or shape. Or if you have shape like this, then it is triangle, right? If you have shape like this, then it is square, right? Along with this input, if you have associated output, then you are in supervised learning. What suppose I have only the shapes alone? I don't know whether it is circle or it is triangle or it is square, right? So output Y is missing here. If Y is not available, if it is unlabeled data, right? If it is unlabeled data, then you are supposed to use unsupervised learning algorithm. And see here, immediately you'll be getting the feedback. Here, there is no feedback at all, right? But in the reinforcement learning, you'll be getting the delayed feedback. I'll explain one by one. Okay. Yes. So let's example here. It's an employability prediction. Here I have some features. This, just ignore this. This is serial number, right? How many features are there in the data set? 1, 2, 3, 4, 5. That is feature 1, feature 2, feature 3, feature 4, feature 5. Yes. So in general, we can consider this. Okay, if you have 5 columns, then it is we can consider these all are features or columns, right? What suppose if I ask you to what is your objective here? Target. Okay, whether job is offered or not, based on my communication skill, based on my CGPA and aptitude level or aptitude skill and programming skill, will you get the job or not? This is not at all called as, hence it is not at all called as what? Features, right? So you have, with respect to this example, you have only 4 features, input features, that is CGPA, communication skill, and aptitude, and then programming skill. And what about this one?
Y output.
Target variable. Yes, it's a target variable, right? Up to this can be represented as capital X. In this capital X, I have 4 features, X1, X2, X3, X4. Is this clear? What is X1? CGPA. What is X2?
CGPA.
Communication
skills.
X3 is aptitude and X4 is programming skill. And what is your Y? Whether job offered or not. Is this clear? Is this clear here? So I just introduced 2 terminologies here. Features, the input features can be represented using features, attributes, or predictors, or one more terminology is independent variable. Independent variable. Why? This is dependent variable. This job offered depends on these inputs. Yes or no? Depends on the CGPA, communication skill, aptitude, and programming skill. Only you will get to know about whether job is offered or whether will you get job or not. Yes. So hence Y is called as dependent variable or target variable or label. Okay. Rest all others are called as independent variable or predictors, attributes or features. So in different textbook, they can use features. In one textbook, they can use attributes. In one textbook, they can use predictors or independent variables. So you should know that all four comes under inputs. Okay, X. And if it is dependent variable or target, or if it is represented as label, then it is Y for that particular example. Okay, yes. Now, moving on to this.
I have one doubt.
Yes.
The previous example is mentioned for the supervised learning. For unsupervised learning, how can I get the target variable? Because for unsupervised
You will
learning,
not. No, you will not have a target variable, right? We don't have explicit target variable, right? Based on the similarity. See, the thing is, okay, I'll see scenario one. Scenario one is nothing but supervised learning. Okay, you have a shape like this. Yes, these many data alone you have in your hand. That is, for example, 100 triangles and 100 circle and 100 square. In total, 300 records you have. In all, each and every 300, each and every record, there is a label, right? In the data set itself. Okay.
yeah.
If this shape represents triangle, this shape represents circle, and this shape represents square. Yes. If you have data like this is labeled data, because for each and every input you will be having associated output, right? Then you are in supervised learning. Then you can adapt any one of the supervised learning algorithm. What is unsupervised learning algorithm? That is, here also I have 100 square rectangle, 100 circle and 100 square. But the thing is, I don't know, because we don't have explicit representation. This is triangle. It's an unlabeled data. This alone you will be having in your hand. Yes.
Yeah.
Yes. What the unsupervised learning will do here is, okay, for example, likewise, if the data are organized, yes, it will do. It will try to find the similarity between their each and every record. After each and every record, it will try to find the similarity, resemblance, right? So based on that, okay, it will try to group. These all are one group. Understood? And these all are can be considered as one cluster or group, or these can be comes under one because all are similar in nature. Comes under likewise. See, we don't have explicit target name, but we can categorize like this. That is comes under unsupervised learning. Don't worry, we will discuss in elaborate manner in the upcoming sessions. Okay. Yes. And moving on to the second example, this is about predicting price. What could be your features or independent variable, and what is your dependent variable?
So
In this
features are
case,
brand, air, engine capacity, mileage,
yes,
distance traveled,
feature
and cab.
1, 2, 3, 4, 5, 6. Into
And label
all
is
of
price.
comes under capital X. Yes.
Yeah.
Independent feature. And what about this one?
Right.
Price is your target or dependent variable, right?
Dependent, yes.
Yeah, based on the brand and based on the manufacturing year and engine capacity, mileage, distance traveled, it's a used car, right? I just wanted to predict the used car, right? So whether it is acted as cab or not, based on that we can you have some prices associated with this. Okay, see here in the previous case and in the previous example and in the upcoming in the second example, what is your observation with respect to your target variable? Here, target variable is real number, discrete real, it's a continuous real value number. Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
it could be, see, it could be anything, or it can be price or height or weight, right? 173.5 or 350,000.56. Likewise, you'll be having some continuous numerical number. Yes, in this case, in this example. But in the previous case, your target is what? Only 2. Yes or no? Yes, if your target variable is categorical, this is categorical, right? Yes or no? Male or
Yes.
female?
Yes.
Benign
Yeah.
or malignant?
Category.
Yes.
Yeah.
Rainy, cloudy, sunny, or all comes under or t-shirt size X, small, medium, large, XL. Yes, all comes under categorical data. What suppose if your target variable Y is categorical in nature, right? See, please remember whether these two examples are labeled data set or unlabeled data set.
Label data set.
Both are labeled data set. Yeah,
Labeled.
both are labeled data set. But with respect to my Y variable, I can do multiple tasks. Okay, see here once again. In the supervised algorithm, here my category is my target variable is categorical in nature. Hence, I am going to do the classification task. What is your task? What is your interest or what is your objective here?
Classification.
Classification. Got it? I'm just trying to classify whether the candidate will get job or not. It's simple binary classification, that too. Yes?
Yes.
But suppose if you have instead of yes and no in some other cases, positive review, negative review, neutral, then it's not a binary, it's a multi-class classification. Okay? So please remember in supervised learning, you can do a two important tasks. One is classification and another one is regression, right? So if your target variable, see, when do you call it as it's a supervised learning? You are in supervised learning. If you have a labeled data set, both X and Y is associated, or if both X comma Y is available, then it is labeled data. You can use you can adapt the supervised learning algorithm, because based on the Y, I can perform multiple tasks. If your Y is categorical, then you are in classification. You can do the classification, right? Yes. But if your Y is continuous real value number, then you can do the task called regression. Got it? Regression. Yeah. This is supervised learning. What about this one? It's unsupervised. So here objective is predicting price. In the previous case, objective is predicting employability, categorizing employability prediction, right? Yes. So in this case, my objective is market segmentation study, right? See, the thing is, it's not okay. What is your observation here based on your data set? What can be acted as X and what can be acted as Y?
Zip code, family income, and number of visits can be X.
Okay, number of visit. Okay.
And average monthly spend could be Y.
I think
Yes.
all are X.
Yes. No, it's not necessary. That is what in a single data set, you can, if you want, it depends on your objective. What suppose as a business partner, if I ask you to find the average money spent in a month, right? Then it should be your Y. Yes. Yes.
Yes.
Yes.
What suppose like in the number of visit instead of count, just assume, okay, normal, frequent, one can be normal, frequent, medium,
Daily.
right? What suppose if your input is like this, and if I ask you to predict or if I ask you to classify based on the family income, based on the average amount spent, just categorize, right? If I ask you to categorize whether it is frequent visitor or medium visitor or normal visitor, then this should be your Y. Yes? Will you agree this? It depends on your
If we have a
objective.
Y,
Can you repeat it, ma'am?
Sorry?
Can you repeat it again, ma'am?
Yeah, in a single data set, my suggestion or my conclusion here is, the summary here is, in a single data set, you can do a prediction, you can do a regression, or you can do a classification, or you can do a clustering. Yes, I have considered this data set alone. Yes or no?
Yes.
But ma'am, on a given data set, we can do any of these, but my
Yes.
final research is based on my objective, right?
Yeah, based on your, that is what suppose if your question If your objective is, I can make 3 objective, Q1, Q2, Q3. Sorry. Objective 1, O1. Not question, right? It's objective. I can make 3 objective for a single problem statement. It depends. It's a business perspective, right? So what suppose if your CEO wants to check whether the customer is frequent visitor or not, right? If I ask you to predict, right? Whether it's a frequent visitor. If I have given one test record, right? Based on this test record, if I ask you to predict the number of visits, it's not number of visit, the frequency of visit, normal or high. We can keep it as high. Yes, normal, high, or medium. Yes. So if I ask you to predict the frequency, in this case, which comes under classification, because this would be your Y. Yes or no? Rest all others are input. Yes?
Yes.
Yes. Yeah. In the second objective, what suppose if I ask you to predict average money spent in a month based on this? In this case, this would be your Y and you are doing regression task. Yes?
Yes.
And the third category is totally different, right? I have not given any explicit objective here. No explicit objective. Consider all field as your input. In that case, what the the model? Yeah, it's unsupervised, right? It's not a labeled. Everything comes under input. So based on the amount income or based on the number of visit and amount spent, right? So what the model will do, it will try to identify the similarity between record 1 to all other records, record 2 to all other records, record 3 to all other records. It will try to group. The groups can be, it can be 2 groups like big spender or low spender, or if you want to make it as 3 groups, big spender, medium spender, low spenders. Likewise, you can group it. This comes under what? Clustering. You are in unsupervised learning because the data set is not labeled data set. It's an unlabeled data set. Yes or no?
So, ma'am,
But it is still features are there, right, ma'am? So that is not labeled. Like family income, you are identifying that zip
No. That is what. Even though data can be acted as from the data set, it purely depends on the objective. What is your question? According to the question, you can fix your inputs. You can fix your target. That is what my conclusion here.
Okay.
Okay.
I mean,
so target is not present in unsupervised.
Sorry.
Target is not available, right, in the unsupervised.
Target is not at all available.
But
After grouping, no. 1 second. After grouping the similar records, at the end, as a analyst or as a ML engineer, what we can do? We can name the groups. For that, you should have a domain understanding. Okay.
Yeah, ma'am, but that would be the target then, right? Like the target would be
after that only that would be the target, but the mission, see, without output, without that much, it's very simple. With only question, if you are dealing, if your model is dealing with only questions, right? You don't have associated answers, right? Based on the question, it will try to identify the question, group the question, right? Then it is unsupervised learning. In the supervised learning, you have question as well as answer.
Okay, sure. Target is not labeled, ma'am. Otherwise, data is labeled.
Not target is labeled, right? Whether you have to check whether that is what again and again I'm telling. Most probably, you can have a labeled data set like this because with respect to this data, I can predict average or I can predict the frequency of visit. It depends on the objective. If your objective differs, if you are in the question, with respect to the first objective, if you are able to map any one of the field as your target, then it's labeled data. If you are unable to map it, then you have to figure it, or if you want to identify the similar data, and after that, if you want to group it, then it is unsupervised.
Yeah, so ma'am, just to reiterate, in supervised and unsupervised, both we will have a objective, but in
Yes.
unsupervised, we will not have Y, the output. And like, for example, let's say the model is doing the clustering, and once the clustering is done, then we can choose to put the labels in, like
Yeah,
what,
you
yeah.
after that you can name it because it's group 1, cluster 1, cluster 2, cluster 3. Instead of that, what I can do? See, it's very
Yep.
simple. I'll use one slides here. Yeah. So just assume I have these many records, right? Student ID, student's name, 10th mark, 12th mark, BE or BTech CGPA, UG CGPA. Yes. Placed or not. For example, 001, student name XXX, 10th mark is 90%, 12th is 82%, CGPA is 7.8, and placed, yes. Yes. And salary or annual income. Annual income is like for example, 10 LPA. Likewise, if you have some records, right, just give me for classification. This is a simple data set. Normal data set. Just consider this as a data set. For classification, what are all the possibilities are there? How many possibilities are there to perform classification?
Many
N number of possibilities.
No way.
Place.
Check the data. Check the
7
data.
possibilities.
7. No.
Ma'am, will you repeat
Placed or not annually greater than.
Actually,
Okay, whatever we
only
choose as
one.
the target, that will be the
Yeah.
classification.
Target should be category, right? That is yes or no. Except all other column, you'll be having only one categorical column. Yes or no?
Yes, ma'am.
Yes.
I can perform one classification task with respect to this data set. Yes?
Correct.
Yep.
Yes.
Yes. What suppose they, I mean, like best achiever award, received, not received, recommended. Likewise, I have one more column. Now,
Two.
yeah, now in this case, you can have two possibilities, right? So if you have a data set like this, X can be, just ignore the unnecessary informations, non-promising informations. Like for example, 10th mark, 12th mark, CGPA, right? What is this? Annual income, everything can be your input, or best achiever award can also be your input, and your Y can be placed or not. This is unnecessary here, right? Placed or best achiever award in the sense like best performer instead of achiever, best performer award in school or college. Yes. Yes. So it can be your
Just like X can be multiple, right? 10, 12
Yeah.
CGPA, and
Yeah,
Y
it
can
can be
also be
anything.
multiple, right?
No. What is this? Your object. I just wanted to predict only one thing. Y cannot be multiple. Y should be always one.
Okay.
Please remember, okay? But there are multiple ways. So you can also give 10th, 12th CGPA, annual income for the the offer, and as well as whether placed or not. Based on that, you can also categorize whether they have received best performer award. This could be a classification. This could be another case, right? And what about regression? One potential task is based on the 10th, 12th CGPA placed or not, right?
Annual
Placed or
income.
not, I can predict the annual income. Yes.
Yes.
Then it is regression. Yes. Or you can also give your input like 10th and 12th, what would be the CGPA? That is also possible. Yes, it depends. What based on the question you are supposed to answer. So based on the objective, the model should predict. Yes. Accordingly, the Y variable will vary. Depends on the objective. It purely depends on your objective. Now, just assume I have not given anything as your objective, right? Consider entire thing as your input variable X. Up to these two, it's supervised learning. Yes. If you consider everything as your input, then it is unsupervised. Unsupervised learning. Yes.
Yes, yes.
What can be done here with this information, with this data? That's it. Up to, I mean, after this, I'll wind up the session.
Clustering
We'll
will
do
be done.
grouping.
Cluster of amount.
We can predict the annual
Grouping
income.
of the persons.
What persons like
Name, by name.
by
Grouping
name?
by name or by
No,
ID.
no, no,
I
no,
think
no,
it will be,
no,
it will,
no.
it will be,
Like
it will be grouped
placed
based
or
on the, all the inputs, right?
Based on placed or not placed.
Okay. See, if your focus is, if you are trying to provide more focus on the marks, right? Whether you can categorize bright student group and or a slow learner, fast learner. Can we group it? Fast learner, slow learner. Yes?
Yes. And then merit students, average, above average.
Yeah, you can also fast learner. Even you can, if you want to add one more group, average student. Yes. Anything
In
else?
unsupervised, we will
Learner, ma'am.
do the clustering, right? Let's say, for example, if I want to specify or find out the criteria for best performer award, that
Yes.
unsupervised will also provide me with that info, right?
Yes, yes, yes.
Yeah. So that can also be one of
But the
use case.
inputs here are not relevant for that, right? Based on the marks, we cannot decide if they
Yes,
are.
because this is like for this you should have either if it is academic related award, then you can do it. But
Correct,
suppose if it
yes.
is performance based for employability, like in the organization, if you want to provide, then you should have more how much project completed on time.
Performance should be taken
Performance should be
mainly.
taken. We should add some more column here if you want to do it.
Tax paid, high tax paid, low tax paid, etc. That we
Super,
can.
super, very good. This is what, see, from the data and from based on this is very important, right? So based on the annual income, I can categorize high tax paid guys or low tax or non-tax. That is a possibility. Yes.
Right.
Yeah.
Depending
That
on
is
the
what-
requirement, we
Yeah,
will
it
be
depends on the
clustering
requirement.
it.
What suppose if your client asks you to categorize from this data, I just wanted to categorize or group these two groups. I just wanted to, I just wanted to figure out these two categories or these two groups. But there is no explicit column, right? Whether they are paying high tax or low tax. Yes, what I can do based on the annual income, you can compute that is called a feature engineering. You can come up with one more additional feature, and based on that, you can categorize whether it is high tax or low tax payer. Yes. Yes. I hope whatever we discussed today is are able to understood.
Yes, ma'am.
As of
Yes,
now,
ma'am. Yes, ma'am.
after
Yes.
this,
Yes.
yeah,
Yes,
thank you. But I'm supposed to finish 60 slides. Still, we are in 30th slide, 50% completed. But anyway, it's very basic and fundamental concept. Without understanding this, you cannot connect the dots even in the upcoming sessions. Okay? Yes. Yeah.
So, ma'am, what going to be topic for next class?
Next class discussion is about the machine learning workflow and pending portions of context session 1. See, it's not like that. Already we have given. I have given the introduction of supervised and unsupervised, right? So with respect to some examples and application related, with respect to application, we have categorized this supervised learning, unsupervised learning concept, right? It will take maximum of 15 minutes of time. And what are all the algorithms are associated with respect to supervised, unsupervised, and semi-supervised algorithm. That's all about the pending portion, right? I just wanted to introduce the reinforcement as well. And that's all about today's topic. It will take maximum, hardly it will take 15 minutes in the next session. After that, ML workflow, the complete ML workflow. If you have a data, what would be your immediate step and what is the next upcoming sequence? Next steps. What are all the steps you are supposed to do if you have a data set? That is what our next discussion. It's available here.
Okay.
Yes.
Ma'am,
Pre-processing. Choose. Yes, please.
apart from the slide and the recommended books, do we have any other study material which BITS will provide us, or is this the
No.
one?
Slides and textbook only.
The
And
textbook, the recommended one,
numerical will be solved by hand.
Yeah, okay. And where will we get that numericals in the Taxila?
Yeah, in the Taxila, like as of now, only first two contact sessions have been uploaded, right? From
Okay.
third onwards, you can get some numericals. Or even in the next class onwards, in the pre-processing step, you are supposed to adapt some mathematical approach. Yes. Yeah.
Okay, thank you.
If you want, along with this content, I can give you some additional reference, like student version. It's a student version for your practice purpose. But don't compare with, okay, we have combined, because don't expect that content from Taxila portal. That is common for all section. Okay.
Ma'am, if you can give that, it will be good. I mean, whoever wants to opt it will use it else.
Yeah, for practice purpose, I can give you some additional problems. Okay.
Okay, sure.
In the annotated slide itself, at the end, I'll update it. I'll upload it. Okay.
Okay, ma'am.
Okay. It will be available in Teams only, not in the Taxila.
Yes, ma'am. Thank you.
Yeah.
Ma'am, just one quick suggestion, opinion from you for practicing. Like, how should I study this? Like, now I've attended your session. So, would you suggest me to go and download the textbook that you told and review? Like, I just want to give you or guide me how I will study, because I want to make sure that I'm prepared for the quiz that I don't know when you will give, maybe after 3 weeks or something. So, daily basis, like just a short, quick study plan or something. Because I have zero idea, ma'am.
Okay.
Or if you would
Okay.
like to drop an email also is fine. It's up to you, ma'am. I just want to know how I will prepare myself. That's it.
So around 150 have joined. I guess 90% of the students or learners are aware of ML. No? Or 50.
I am not aware that much.
Okay, fine. Let it be. Okay, 50%. Okay, 90% is not, and they are not aware of what is ML and the things, right? So please start a study about mathematics, like linear algebra, right? Linear algebra, vector, scalar. Yeah. And first start with maths. Matrix representation. In the partial derivative, it's not necessary that you should solve the very bigger problem and all, right? It's not necessary like school and colleges. But what you can do, you should refresh, you just collect the formulas for the derivatives, partial derivative, and for probability, the conditional probability formula and all. So with respect to formula, the basic thing only, but with respect to formulas, you just try to refresh the concept so that in the live session, you can connect it. That is one point, one suggestion. So start with maths, as well as if you want to implement the concept in a better way. Are you aware of Python programming?
Yes, ma'am. We had the zero course, the refresher session for Python.
Yes. So then start with what?
The refresher course, yeah.
Refresher course, or it's not like refresher course. You can do a self-study as well, right? We are like you should be proficient in Python, right? Should be pro in Python. Then it's not, because you should write your code in an optimized way. That is what. You all know the basics and all, right? But try to study about the latest packages, libraries available in the Python. Yes, that is important.
Okay.
Okay. And
Ma'am, books for linear algebra and derivatives, is it part of the slide? Is it already mentioned in the slide?
No. It's no. That is what. There is no specific. You don't need to study about like all the concepts available in linear algebra. Okay. I just wanted to introduce like line equation, linear relationship, non-linear relationship. That's all. Don't worry. Next class, I'll give you the set of topics so that it will be easy for you to prepare for the upcoming third class. Okay. First two classes are basics only. Okay. Okay. Shall we wind up the session?
Yes. Yes, ma'am. Thank you.
Thank you.
Thank you very much, ma'am.
Thank you.
Ma'am, quick
Thank you,
question, ma'am.
Thank you.
Hello.
Yes, please.
Yeah. So, ma'am, those maths problems, matrix determinants and derivatives, would there be direct questions in mid-sem or end-sem on that, or would there not be?
No, and that is what. It's not a math course, but in order to implement or in order to adapt the machine learning, you should aware the math. You should aware of gradient descent, the derivative, partial derivative, or the linear regression and all, right? So in that case, without knowing the equation, for example, if I ask you to give me the line equation, y is equal to mx plus b. See, it's not new to you. We all know the equations. We all know, but you should refresh the topics. That's it. Parabola equation or the bell curve. So all such terminologies are not new to you, but the thing is you should refresh. But math can be explained by in the live class by me, right? Don't worry.
Okay.
Ma'am, sorry, just to reconfirm now till the next Sunday, I mean till the next class, that is tomorrow. I mean no, next Saturday. So should I specifically learn something to come up except refreshing the session today? Should I go read something or do something, ma'am?
Okay, give me a time, 1 day time, right? In the Teams chat, I'll post some topics.
Okay, perfect, ma'am. Perfect, please. Thank you, ma'am. Thank you.
That
So
will be
much.
helpful.
Yes. Today evening I'll post it. Today evening I'll post it. Yeah.
Great, sure, ma'am. I'll follow that. Thank you,
Just a
ma'am.
doubt.
Thank you, ma'am. Great session.
Just a doubt.
Thank you.
Hello.
Thank you all. Don't worry, right? We are here to help you. Don't worry, right? Don't get panicked about like math, the equations and all, right? Don't worry.
Ma'am, during the course, you will also like nudge
audible?
on the topics that will be asked for end semester and mid semester, because I'm concerned about those exams.
Sorry, examination.
No. I'm just asking that during the teaching sessions, right? You will also nudge on the topics which will be important for mid sem and end sem, because I'm like concerned about passing those exams.
Whatever is discussed, it's aligned with our syllabus as well as with respect to mid semester only.
And also, ma'am, like if you can share any sample questions that going to be
it is
asked
available.
during
It's
mid-sem.
available. It's available in the Taxila portal. In the past, one folder is created, past previous question paper. You can refer it.
All right.
Okay,
Thank you,
ma'am.
ma'am.
Ma'am, ma'am is just a just a doubt, ma'am. While we refresh these topics, and where do we apply these ones? Like, is it in Python coding or any platform or algorithm? What kind of things we will be applying this information?
In the assignment you are supposed to implement the ML algorithms, right? For that,
So
see,
there is any structure? Just one more doubt for within that. Is there any structure to have that algorithm, or is it just we can build that data structure from our side?
I would suggest there are multiple predefined libraries are available. By just calling the libraries and you can do your implementation. But when I started to study about this machine learning and all, I have done one certification course there. I have to implement from the scratch without using third-party library. So
Yeah,
if
that's
you
the
want to
best thing, right?
if you want to understand the concept clearly, but for assignment purpose and for your project implementation and even for in companies, you can use it. But for
Yeah,
learning
we use
purpose,
in
I would
companies, but
suggest
yeah.
yes, but I would suggest from the scratch. It's not like that you are supposed to implement for example, if it is a linear regression or it's not necessary that. But the thing is, at least some functions you have to define by your own from the scratch.
Yeah, okay.
Yeah.
Yeah, thank you. Thanks a
This
lot.
will help. This will improve your learning as in this will improve your understanding. If you want to modify, if you want to improvise your model efficiency, then you will get clear understanding about the model and all.
Thanks a lot. Yeah.
Yeah.
Thank you.
Shall we wind up? I have another session back to back.
Thank you so much.
Yeah,
ma'am.
just
Yeah. Thank
Thank
you
you,
all.
ma'am.
Thank you so
thank you
much.
so much,
Thank you.
ma'am.
Yeah.
Thank you so much, ma'am.
Thank you. Bye bye.
Ma'am, I had one question actually.
Yes, please.
You mentioned that we have to be pro at Python, right? So, are there any specific areas that we should focus on?
Yeah, that is what. If you want to do it by yourself from the scratch, then you should be aware of the data structures like list, tuples, dictionaries, data frame, yes, and the manipulations of data frame and series and all, right? And the next thing is, and you should aware of like even the SQL as well, the queries, optimized code, the list comprehension and all, everything should be.
Okay.
Right? You should aware of all such. But the thing is, if you want to use the predefined third-party libraries, then it's totally different. If you want to do it by your own from the scratch, then you should be aware of Python, all concepts of Python, right? The class, object related things and all, object oriented concepts and all, everything you should aware. Yes.
Okay, ma'am. Thank you.
So this course consists, see, with respect to course content, it's numerical as well as content wise we can explain. But the thing is, in real time, if you want to implement it, you should be aware of Python as well, right? For implementation point of view. Yeah. Thank you all.
Thank you, ma'am.
Yeah. Bye.
Thank you very much, ma'am. Have
Thank
a
you,
great
ma'am.
day.
Yeah. Thank you.